This is Rylan Grace. He's on an interstellar mission from Sol, our sun, to the Tau Ceti system, about 11.9 light years away. And somehow he'll get there in just a little over 4 years. Wait, did I hear that right? Tau Ceti is almost 12 light years away, but Grace reaches it in only 4 years and 2 months. So what is this? Is the movie just breaking the laws of physics? Well, not at all. It's actually taking advantage of the very same laws of physics we experience. And E equals mc squared. That's exactly what makes this journey possible. He actually encounters an alien intelligence. But just how likely is it to find intelligent life beyond our solar system? As a bonus, we'll also be releasing all 3 simulations we built for this video, available free for our channel members. So that's all coming up in this video. So first, a quick recap of the movie, just in case you've forgotten the plot. The story begins when the sun begins dimming because of a microorganism that feeds on stellar energy. Every nearby star is affected except this one, and that is Tau Ceti. Tau is the 19th letter of the Greek alphabet, while Ceti refers to the constellation Cetus. Together, Tau Ceti simply means the 19th brighter star within the constellation Cetus. Just like how Alpha Centauri is the first brightest star in the Centauri system, Rylan Grace is sent there to investigate why Tau Ceti remains unaffected. That's why the mission is called Project Hail Mary, just like the phrase in American football.
Far sideline, Jacoby Jones has it at the 20.
It's the last desperate attempt with very low odds of success. The crew also has to spend years in a medically induced coma. You see, most people simply can't survive that process. The failure rate is incredibly high, and only a tiny percentage of humans carry the rare genetic traits needed to endure it, which makes the candidate pool extremely small. And so Grace is chosen because he has both a scientific background and genetics to do the mission. And the mission planners eventually realize that keeping a tiny crew awake for years in deep space is basically inviting disaster. So instead, they remove the human variable almost entirely. Everyone sleeps through the journey and only wakes up once the real mission begins. But the real star of the movie isn't actually Grace. It's this little creature, the astrophage. Astro means star, while phage means eater. Quite literally, it's a star-eating organism. It consumes stellar energy, which causes stars to gradually grow dimmer. Since Tau Ceti appears to be the only nearby star that survives the astrophage outbreak, the movie suggests it may hold the key to saving our own sun. Interestingly, Tau Ceti is also broadly similar to our sun in terms of stellar classification, so it's at least a plausible place to look for answers.
Every star was infected by its neighbor except one.
Tau Ceti?
Tau Ceti, that's right, 11.9 light years away. It is uninfected despite being well within the
Even though the astrophage is entirely fictional, and the weir base its underlying idea on Einstein's equations, E equals mc squared. This formula describes the relationship between mass and energy. Because the value of c squared is extremely big, and enormous amounts of energy can be stored in a tiny amount of matter. Basically, it's the same principle behind nuclear reaction. We've actually built a simulation for this. If you place 1 milligram of astrophage inside a solid cube of iron, it melts almost the entire block instantly. And if we scale it to match what's shown in the movie, it completely blows it apart. This is exactly why the spacecraft uses astrophage as its fuel. It allows the engine to continuously accelerate at about 1.5 g. That's roughly 15 meters per second for every second. So it just keeps getting faster and faster. Unlike a normal rocket that burns for a few minutes, this one keeps pushing almost the entire trip. As a result, Grace reaches an enormous fraction of the speed of light, that he arrives at Tau Ceti after only a little over 4 years on board. But you see, Tau Ceti is almost 12 light years away, so does that mean that Grace is traveling faster than light? Not exactly. The movie relies on a very real prediction of Einstein's theory of relativity, called time dilation. As an object moves faster and faster, especially as it approaches the speed of light, time passes more slowly for that traveler, compared to someone who remains stationary. And that stationary observer is us, here on planet Earth. So while many more years pass on Earth, Grace only experiences 4 years on board the spacecraft. The phenomenon is described by this equation. Here, delta T is the time experienced by the moving observer, or Grace in this case. Meanwhile, this T is the time experienced by someone who remains stationary on Earth, and V is the spacecraft velocity. But as we've discussed before, the ship doesn't travel at a constant speed. It accelerates continuously at 1.5 g. So its velocity is constantly changing. That means the amount of time dilation is also changing throughout the journey. We actually mapped his entire trip from Earth to Tau Ceti. At the time of launch, the ship is still moving slowly, so there's almost no time dilation. But as the spacecraft keeps accelerating, the effect grows bigger and bigger, reaching its maximum around the halfway point of the journey, which is here. This is just before the ship flips around and begins decelerating toward Tau Ceti. And this time dilation effect is made even more obvious in this scene. When Grace's message finally reaches Earth, Commander Eva Strad has aged by decades. I mean, you can see it, her wrinkles, her hair, everything. Grace has only aged about as much as you'd expect after a few years of mission. And then there's Earth itself. Strad is sailing through this vast ocean of ice. Just look at how much the planet has changed while Grace was away. This is because, according to the movie, if they don't do something within 30 years, Earth freezes over. The only thing standing between humanity and a new ice age is this guy, floating alone in the emptiness of space. But the real Earth is changing too. We've pushed nature so far away from its natural balance. I mean, this is abnormal. And so is this. The strange thing is, at some point we already knew how to work with nature. Long before modern agriculture, First Nations peoples across Australia managed the landscape like a living garden. They understood moisture, wind, humidity, and the rhythm of the seasons. Using carefully controlled cultural burns, they reduced fuel loads and helped the entire ecosystem stay healthy. And they did that for tens of thousands of years. That's why supporting work guided by indigenous knowledge is incredibly important.
I'm in Southern Australia to meet the people who are bringing back a 40,000-year-old ecosystem by using a mixture of First Nations ecological knowledge and contemporary climate science.
That's Planet Wild doing exactly that. They're basically like crowdfunding for nature, a conservation organization bringing together a global community of people who want to protect the natural world. Every month, they partner with a different team restoring or protecting an ecosystem somewhere on the planet. Just like the project here in Australia, they were working alongside Ngarrindjeri elders to restore this very ecosystem. More than 25,000 members helped make this mission possible, and every project is documented on YouTube, so you can actually see where your support goes. Instead of wondering whether your contribution made a difference, you can often watch the results unfold within the first month. So if you'd like to be part of missions like these, you can join Planet Wild for as little as $6 a month. And I have a little bonus for you. The first 100 people who sign up using my code BEYOND27 will have their first month covered by me. Just scan the QR code on screen or use the link in the description. After that, you can cancel anytime. If you want to see them in action first, check out their mission in Australia, linked in the description. Now back to the video. Project Hail Mary introduces a rather different approach to interstellar travel. In many science fiction movies, astronauts experience gravity because the spacecraft spins. That rotation creates an artificial gravity through centrifugal effects, so people are able to walk around almost as if they were on Earth. You see this in many films. Interstellar, The Martian, but not here. Grace isn't spending most of the journey inside a rotating spacecraft. The Hail Mary ship is capable of rotating, and we briefly see that in this scene. But that's not how it creates gravity for most of the trip. So what makes this different? The answer is acceleration. If you look closely at the briefing scene, the presentation actually states that the Hail Mary travels using constant acceleration. And this isn't just something implied by the movie, it's also verified by the data released by Andy Weir himself. As you can see, the spacecraft accelerates at 15 meters per second squared, or roughly 1.5 times Earth gravity. You've probably experienced this yourself. When a car suddenly accelerates, you feel yourself pushed back into the seat. It's not because something is pulling you backward, it's because your body resists changes in motion while the car accelerates forward beneath you. The Hail Mary works on exactly the same principle. If the spacecraft accelerates in this direction, the crew feels an apparent force in the opposite direction. The floor pushes against their feet, so to them it feels just like gravity. That's why Grace can stand, walk around, and work almost normally, without relying on spinning spacecraft. In the movie, that acceleration is set to about 1.5 g, but in our simulation, you can explore other possibilities as well. We've included 0.5 g, 1 g, and even 2 g. As you would expect, the higher the acceleration, the stronger the relativistic effects become. For example, if Grace completed a direct return trip from Tau Ceti, the age difference between him and the people back on Earth would be almost 19 years. While Grace experiences only part of that journey himself, Earth continues moving forward in time. You can explore all these scenarios inside the simulations we built, and it doesn't stop there. You can also change the destinations entirely. You can fly to Proxima Centauri, Alpha Centauri, and other nearby stars simply by selecting them here. You can even explore the surrounding stellar neighborhood and experiment with different mission profiles. Everything is available in the complete simulation through our channel membership. Just click the link in the description or scan the QR code on screen. There's another fascinating idea in Project Hail Mary that's worth exploring. So, eventually Grace encounters an alien intelligence. And unlike the classic science fiction image of little green men with oversized heads, Rocky looks, well, like this. But what makes Rocky interesting is the way he experiences reality. Since we've talked a lot on this channel about perception and consciousness, Rocky is a great example of just how different another conscious experience could be. He doesn't even see the universe the way we do. I mean, instead of vision based on visible light, he perceives the world through sound, vibrations, and likely parts of the electromagnetic spectrum that humans don't naturally sense. Just imagine trying to explain color to a creature that has never experienced light. This is just like trying to explain what Rocky's world actually feels like. There's another detail that's also very important. Rocky comes from the planet 40 Eridani. It's a world with an incredibly dense atmosphere, around 29 times the pressure of Earth. A world like that would naturally result in life forms very different from us. And perhaps that's also why Rocky doesn't rely on external computers the way we do. You can actually see this in the movie. Rocky performs much of the language processing with its own biology, using his body as the device. For him, the computer is effectively built into his body. And this leads us to a much bigger question. How common is intelligent life beyond Earth? This exact question was formalized by astronomer Frank Drake through what's now known as the Drake equation. This isn't really meant to predict the exact number of alien civilization. It's more like a framework. It breaks the problem into a series of unknown factors, and depending on what values you choose for those factors, you can end up in a very optimistic universe or a very lonely one. So let's start with our own solar system. Under a moderate set of assumptions, the probability of finding another intelligent civilization here is around 10 to the minus 21. That's a decimal point followed by 20 zeros before you even reach the first digit. For comparison, that's about the same order of magnitude as randomly selecting one particular grain of sand from all the beaches on Earth, and then doing it again and again, a few times in a row. In other words, essentially zero. Even if we extend our search to nearby stars, the probability is still tiny, around 10 to the minus 8. Next, let's move to 40 Eridani, the home system of Rocky in the movie. Even under optimistic assumptions, the probability is only about 1 in 30, which means that even with the fictional universe of Project Hail Mary, Grace meeting Rocky is still a lucky event. Only when we scale up to the entire Milky Way do the numbers begin to look encouraging, at least under moderate or optimistic versions of the Drake equation. In other words, the probability per planet may still be incredibly small, but multiply that by the enormous numbers of potentially habitable worlds in the observable universe, and the expected number of intelligent civilizations increases dramatically. But then comes the obvious question: where is everybody? Well, the simplest answer I can give you now is scale. Here's one way to picture it. Imagine downsizing the entire Milky Way until it's the size of the North American continent. How big do you think the Earth would be? A state or a city? Not even close. Earth would only be about 6 micrometers across. That's roughly the size of a single virus. Yes, so imagine we're just a virus trying to find another virus somewhere across an area the size of America. That's exactly the scale we're dealing with. We're often so caught up in our own achievements, our politics, our conflicts, even our own importance. But compared to the scale of the cosmos, our entire civilization exists on a planet that's almost invisible. When our civilization fits on something this tiny, it becomes much easier to understand why we've never met anyone else. Our universe is operating on a scale that our brains were never built to understand intuitively. Once again, thanks to Planet Wild and to the Ngeri Ngeri community for doing the real work. Link is below if you want in. See that mission in action right here.